Hello and welcome. You should be on page 38 of your pre-algebra quarter 2 notebook. We're going to continue with part 3 of our graphing using table of values. So, graphing linear equations. This is our final example of using a table of values to graph a linear equation. Of course, step 1 is to ask yourself, is my equation written in function format or is y by itself? In this case, y is not by itself. It has an x added to it. So I'm going to use my opposite operation to get this x to the opposite side. If I have plus essentially 1x, I am now going to minus 1x from each side to get that y by itself. And now I have minus, I'm going to just put a 1 in front of these, minus 1x plus 1. And I'm going to leave this minus 1 here, even though algebraically speaking, mathematicians would write that equation this way. I'm going to leave this minus 1 here because when I'm using the table of values, I want to remember that this equation with that negative sign in front of the invisible 1 is telling me to multiply my value of x by a negative 1. So let's pick our domain, our x values, and I'm going to use, I don't know, let's just do 0, 1, 2, and 3. So if x equals 0, I'm going to substitute in y equals negative 1 times 0 plus 1, multiply first, and I get y equals 1. Now I'm going to look at x equals 1. I'm going to substitute in negative 1 times positive 1 plus 1. Negative 1 times positive 1 is negative 1 plus 1, so y equals 0 when x equals 1. Next value is x equals 2. I'm going to substitute in 2 for my x. I'm going to multiply first. I have negative 2 plus 1, and y will equal negative 1. And final value, x equals 3. Substitute in 3 for x. I'm going to multiply negative 3. Negative 1 times 3 is negative 3. And I will add negative 3 plus 1 to get minus 2. Now I'm going to plot and create my line. When x is 0, starting here at the origin, y is 1. When x is 1, start at the origin, y is 0. When x is 2, 1, 2, y is negative 1. And when x is 3, 1, 2, 3, y is negative 2. So there is this line. So you can see that when I have linear equations, they result in lines. But we know that there are such things as horizontal and vertical lines. So table of values is a super effective way to graph these types of lines. So let's take a look. When given x is 5. X is the number that's there. This is clearly telling me, this equation, that x equals 5. So I'm going to put 5 in there. And essentially, I'm going to choose my y's, right? Because, well, x is always 5. So y could be, well, negative 2, 0, or 2. Doesn't really matter. It could also be 100, but I don't have that to graph on this. So let's graph this now. I start at the origin, 1, 2, 3, 4, 5, negative 1, 2. 1, 2, 3, 4, 5, 0. 1, 2, 3, 4, 5, 2. And just imagine if I had the value of 5, I'd go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If I had the value of negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You can see that no matter where I plot any of these y's, x is always 5. So this will result in a vertical line. Equations that have x equaling a number are vertical lines. Y-equal equations are the opposite. I am going to, of course, when I get y, that is going to be the number for y. So I'm going to put negative 2, negative 2, negative 2 for y. Y equals negative 2, so I fill in negative 2 into that table. Now I'm going to choose my x's. And doesn't matter again. So maybe I choose -2, 0, 2. Just kind of positive and negative. So I'm starting at my origin, and x equals -2 and y equals -2. If x equals 0, starting at the origin, y equals -2. If x equals +2, y equals -2. And you're going to see a horizontal line is forming. So equations that have y equals a number result in horizontal lines. Let's take a look at page 39. If you're done with this lesson, you can pause the video here, but if you're thinking, I want some more practice, I'm going to do the try it problems for the remainder of this video. So take a look if you think it will help. Make a table of values for the following equations, then graph. If a domain is given, use it. So remember, domain represents values of x. So in all the examples I've been doing up to this point, I have been choosing my x. In these first two equations, you can see that my domain is given. I must use x equals -1, 0, 1, and 2. In this equation, I must equal -1, x equals -1, 0, 1, and 2. So if you're given the domain, you must use those x values. So number one, I want to ask myself, is this written in function format? Well, yes, it is. Y is over here by itself. So I'm going to substitute in my values of x for each of these equations. If x equals -1, y equals 3 times -1, so y equals -3. If x equals 0, y equals 3 times 0, y equals 0. If x equals 1, y equals 3 times 1, so y equals 3. And if x equals 2, y equals 3 times 2, y equals 6. And we're in a position where I can't graph that anymore, so I'm just going to graph these first 3 points. Starting at the origin, -1, -1, 2, 3. Starting at the origin, 0, 0. Starting at the origin, 1, 1, 2, 3. Oh, I think I can go up to 6. 1, 2, 3, 4. Nope, I can't. So I'm not going to graph this next point because I don't have a y equals 6 value, and I'm going to connect the dots. Let's look at this next one. Is y by itself? It's not. So I need to rewrite this. Y plus 2x equals 3. I'm going to use my opposite sign to get this opposite operation to get this to the opposite side. And I have y equals -2x plus 3. So that is my equation in function format. I've been given my domain values. So if x equals -1, I need to substitute that in. I get y equals -2 times -1 plus 3. -2 times -1 is 2 plus 3, and y equals 5. If x equals 0, y equals -2 times 0 plus 3. Y equals -2 times 0, which is 0, plus 3, which equals 3. If x equals 1, y is going to equal -2 times 1 plus 3. Y will equal -2 times 1, which is -2 plus 3, and y equals 1. And finally, if x equals 2, substituting in -2 times 2 plus 3. -2 times 2 is 4. -4 plus 3, and y equals -1. Now it's time to plot these points. I have -1, 1, 2, 3, 4, 5. I have 0, 1, 2, 3. I have 1, 1, and 1, 2. Oh, it's not a very good. This does not look quite right because you can see that this line isn't perfect, but I'm not going to plot that last point because that line is a little bit wonky, and we're going to use that as a line. Alrighty, look at this friendly equation. It looks like it's just an x equals, so I'm going to substitute that in, -2, -2, -2, -2. And it does not matter my values of y. Let's do -2, 0, 2, 4, 6, 8, blah, blah, blah. Okay, x equals -2, -2, -2, 0, -2, 2, -2, 4, and x equals number results in a vertical line. Woo! Let's take a look at this equation. Y equals 1/4 x minus 3. Is y by itself? Is it written in function format? Yes, it is. But I have a fraction coefficient. So I'm going to look for multiples of that coefficient. I'm going to do 0, 2, 4, 6. Knowing that I can't plot the 6, I'm going to be okay with that. So let's take a look. If y equals, x equals 0, y equals 1/2 times 0 minus 3. So y equals 0 minus 3, y equals -3. If x equals 2, y equals 1/2 times 2 minus 3, y will equal 1 minus 3, which equals -2. If x equals 4, y will equal 1/2 times 4 minus 3. 1/2 minus 4 is 2, so y equals -1. And if x equals 6, y equals 1/2 times 6 minus 3. 1/2 times 6 is 3, minus 3, so y equals 0. Alrighty, plotting the points, and I'm going to have 0, -3. Then I'm going to go to 1, 2, -2. And then I'm going to go to 1, 2, 3, 4, -1. I can't plot my 6, so I'm going to leave it. But you can see that it's going to cross that x-axis at 6. Alrighty, final question in these try-it problems is, which of the following graphs does not represent a function? And explain our reasoning. So when I'm looking at graphs, a great way to determine if it's a function is that vertical line test, right? Are there more than one point if you use a vertical line across? And I can see that in a vertical line, it clearly does not pass the vertical line test. In fact, my table of values shows 4 points along the same vertical line. So number 3 is not a function because it does not pass the vertical line test. And that is all for these try-it problems. If you stayed on to listen, thanks, and see you later.